In this lesson, we'll create the scanning lines. So let's finish up with this node. I'll add a null and name it out prim animation. Of course, before that, we can also cache them out. Prim animation, the entire frame range, and save to disk. Okay, so now let's head back, create a new GeoNode, and we name this scan lines fx. Dive inside. We want to create another sphere. This sphere doesn't have anything to do with the older sphere. We also select polygon, maybe just hit 7 here for the frequency. I create a transfer node, make this really small, like 0.1 or something. Let's also ghost other objects so we can see the other sphere, how big it is, and maybe we need to go lower, 0.01 actually. So I think this is good. So let's object merge the primitives. We just search for the spread effects, and here out prim animation. So now we just took this prim animation from the other geometry file. This is a really nice feature in Houdini. Right now I just hide other objects to make sure I only see what's inside this node. And I say here in prim animation. Now I will use a delete sop and delete by expression as we did earlier, and say at cd.x smaller than 0.5. We delete the points. Something's not working. Let's see. Primitives. Yeah. So it's actually cd.z because we don't have .x. It's actually the red channel. And we don't have any red channel right now. So here it should be maybe 0.1 or 0.01. So we have the entire range of points. Something like this. And now we just have the shell of the primitives that we need and that will be visible in the render. Maybe this layer of black, it's too much, so we should go 0.1. or 0.2. So it's a matter of tweaking this thing out. Yeah, so on the left side we have the center sphere, and on the right side we have the primitives animation. So now we want to create some lines emerging from the center to the primitives that are forming up. So what we can do right now is create a particle network just to have some movement. But before that, I think we need to add some normals to the sphere. Actually, some point normals. Let's check them out. Okay. We also need to add a velocity attribute. So we put down a point wrangle and just a simple line of code. And we say v because it's a vector. At v, so vector, and then is the parameter velocity equals to the normal multiplied by channel float, name mult. So what happens here is that we take the normal, transform it to a velocity, and then we may need to multiply this with a float. If we put this to 1, it's equal to the normal, and if we go here, we can visualize this. So this is the velocity. Of course, if I lower this, it gets smaller. If I put it to 1, it's equal to the normal. Let's say what happens. So we say here velocity, and now I need a pop network again. And let's see what happens. You see that there are a lot of particles moving alongside the normals or the velocity. So of course we don't want so many particles. We should go inside and let's say we want, I don't know, 900 maybe, and a life of under 1 second with a variance of 0.2 seconds. Let's see how that looks. Maybe still too much, but we need to see that. We leave it as it is for now. So then what we need to do is to rate those points to the sphere itself. So we say minimum distance, and now if we disable the guided geometry, so what happens, the particles are moving around the sphere a bit. Maybe if we go and change the velocity to 5, yeah, we have some small movement there. Okay, so now we need to use the same particle network because we have an ID here of the particles, and we need that attribute to create some lines between the points. So we need to use another ray, and this time we ray the same particles over the primitives. Let's see how that looks. So I just template this, and yeah, it's pretty crazy, as you can see. I can leave it like this, or what I can do is just scatter some points around the primitives. So let's do that really fast. It's very similar to what we did with the growth effect. So I say copy to points, then I create a sphere with a transform. I do this really often, and then I just scatter some points over the primitives. So maybe we just say 10 points or 100 points, let's see. So right now we just have some points scattered all around. And now we add the spheres. Of course, they are really big right now. So let's go with 0.1, too big, 0.01. Yeah, I think this looks right. And now I just want to ray the particles here. So we see there are a lot of particles that are raying over the spheres. One issue that we have, of course, are those particles at the beginning that do some strange stuff. So of course there's a way to fix that. There are multiple ways actually, but I think I just follow the frame number, and what I can do is tell the popnet to start at frame 10 maybe. Yeah, so now if we merge those two rays and disable this one, we should have some points in the middle and a lot of points moving alongside the primitives. Of course, we can, tweak this a lot, but right now I think it's fine for this example. And what happens is that we have the same particle network, that it's rayed into the main sphere in the center and also rayed into the other spheres on the edges. So right now what we can do is make an add sop, and here we say polygons by group, and right now it's trying to create lines for each particle, but not keeping in consideration the ID. And we say by attribute and put here ID. And right now, so for example, if there's one particle with the ID 1 here and the same particle with the ID 1 here, it creates a line in between. So we get this really nice scanning effect. And now what I want to do is create a ramp over a color ramp to control maybe the thickness of the lines, and also maybe add some noise displacement. So before that, let's just do some cleaning around here. Okay, let's try to create that ramp over the length of the line. Of course, there are again several ways to do this. Let's do an attribute wrangle this time, an attribute drop, sorry. And what we can do, we can just measure the length of the position and plug it into the CD, and you see there's a gradient appearing over the lines. What we can also do is add a ramp, change it to spline ramp, plug it into here, then we go outside, and now we can control how it behaves. I think we need also to do a fit range maybe. Oh, actually, I think I know what happens. We just have 2 points, one at the beginning and one at the end, so we need to do a resample. So this adds a lot of points over the lines, and now we have a lot more control over the colors. We can also change this to have a lot more points. We also need this for the noise. So right now it's not so many points, so maybe 0, 1. Yeah, something like this is nice. And of course now we can just play with this with the ramp. We don't need this fit range, sorry for that. And right now we can just have a nice transition over here. What we will do with this color is again using it as a mask like in Photoshop, so we can displace, add a noise and displace the position of the lines and keep the same position where the color is black. Let's do that now. We add another point VOP. Let's see, we need to take the color. Let's add a turbulent noise. Plug in the position. Then we do an add the original position with the noise and plug it into the position. And of course now everything is pretty messed up. But first let's try to keep the black points into the same spot. So we need to multiply the noise with the actual color. I will also, or maybe not, let's just use the color here and plug it into here. So now as you can see, the black parts remain into the same position and only the noise changes. Let me just organize this a bit. Of course, what we can do is just promote these parameters. We can just play with other types of noises. So we can change the frequency, the amplitude, just a small noise here. Yeah, so I think that looks good. And there's also the offset, so you see that it has some movement. Of course, I can take this parameter and paste the relative reference. What this does is it keeps the same number on each channel, so it's X, Y, Z. And now we can just use a variable, the time, multiplied by 0.1, let's say, and see how things are moving. Maybe too fast. Or I think it's pretty nice, I think. Let's see. Okay. Also, what I can do is use this color in the shader later. So this is really nice, but I would need for the color another type of gradient. So then I think we need to go back and make some changes. So actually this one, because we already know how it looks right now, we don't need it to plug into the color. We just bind export. This exports a parameter that is not visible here. It can be whatever, so I say mask, and I just move this ramp here. Maybe I just put this at to be a vector just to make sure. Sometimes Redshift doesn't read this if it's not a vector. And now we don't see anything in the viewport, but the parameter is still there, the mask is still there. And now here it doesn't work anymore, of course, because instead of the color I need to do a bind. This is bind import actually, and say here mask. And you see it goes back again. And now we have a separate channel for the color actually. So if we go back inside here again, we can make another ramp. Take the same length, and this one we should plug in into the color. So this is the ramp 2, let's say, and yeah, we just need a spline ramp as well. So yeah, I think this is good for now. We will tweak that in Redshift later. So it will just be like a gradient from something darker to something lighter. So we have the color separated from the other parameter that controls the noise. And here we say maybe calculate mask and CD. And here we say noise. And of course what we can also do is add a polywire to this because we want to render it. Of course we can also do this at render time, but unfortunately Redshift doesn't have a lot of options there right now to use the color parameters, you know, without using a polywire. So let's do that. If you remember, we have from the popnet, we should have an edge that it's also present here and also here, of course. So what we can do is make maybe an attribute wrangle, plug it into here, just make sure that we still have the edge. Okay, and we can calculate the radius of the polywire. So we say radius. And what happens here is if we put a polywire, right now it's messed up because of course the radius is really big. Also I would like to save the scene because the polywire sometimes it's very heavy and it may crash. So what's nice about the polywire is that in this wire radius we can just put here a parameter that's called radius. So now right now it doesn't have anything to read because if you have a look here, there's no radius around. So here I can say float at radius equals to, maybe equals to the age of the particles, so equals to at age. Let's see what it happens. So of course this is really big. And now I would just multiply this with a channel float that's called mult from multiplier. Now it's 0, so maybe I go with 0.0001, let's say. Okay, so now we're getting somewhere. Of course, another problem would be that the divisions are too low, and we can do two things: just increase the segments and also the divisions maybe to 12, and this will take a while to calculate. So you see right now it's more of a rounded shape. If we need more resolution here, we can always subdivide this at render time also, but I think it looks pretty nice for now. I will just put like a blue color. This is like more like a post-processing thing when I add the blue color. What we can do, we can also add an animation to these lines so they grow. For that we can use a curve SOP, so we can add that here after the resample. Because of the performance issues with the polywire, we want to see this curve on the straight lines. So I just want to animate the second view. This is the endpoint of the lines. So if it's 0, there's no lines, and if it's 1, they reach out their maximum position. So right now, if we have a look, they start at frame 10, and if I want to do like a really short animation, I can just put a keyframe here, holding Option or Alt, and just go maybe a few frames and hit 1. So right now they will start like this, not really, they have like a easy in effect. We can just move this one here, so they are more natural to me. Let's see, you see, so I think this is looking pretty nice already. Let's see the polywire again. Yeah, okay, so everything looks really nice. Let's add a null, and we name this out scan lines. In the next lessons, we will set up some render nodes, the shaders, and also some post-processing for the polygons and some VDB growing of the sphere. See you in the next one.